We take one more example from Mason's gain formula to further clarify the concepts. We have this signal flow graph for a system, and we want to apply Mason's gain formula to find a transfer function between this output signal y5 and the input signal y1. So we apply this formula. K is the number of forward paths. So what is K for this particular system? There are two forward paths. We can follow this path to reach from this signal to this output signal, or we can also follow this signal. So there are two forward paths, and remember that this, for example, is not a forward path, because for this path we have to pass through these nodes for multiple times. So K, number of forward paths, is equal to 2. The gain of first forward path T1 is G1 multiplied by G2 into G3. Gain of second forward path is 1 multiplied by G4 into G3. So delta is given by 1 minus sum of loop gains. Sum of loop gains. So how many loops are there? This is one loop, second loop, third loop. Is there any other loop? What about this one? If I start from here, move here and come back to this point. Start from here, move in this path, we come back to this point. So there are 4 loops. This one is also a loop. We are moving in the direction of arrows, and we come back to the same point. So there are 4 loops. हाँ तो 4 loops हो गई. This one is one loop, second loop, third loop, and 4 loops. Any other? So we have 4 loops, and delta is given by 1 minus sum of loop gains. What is loop gain for first loop? That is this one minus G1 H1. For this one, minus G3 H2. For this one, G1 G2 H3, negative sign over here. Fourth, G4 G3 H3. One minus sum of loop gains plus gain product of 2 non-touching loops. Sum of gain products of 2 non-touching loops. Is there any non-touching loop? This loop is non-touching loop with this one. And what about this and this? These are touching loops because this node is common between the 2 loops. Likewise, this one and this loop, these are also touching loop. This node and this node is common between the 2. So there is no other combination of non-touching loops. There is only one combination. There is this one and this one. These are non-touching loops. So gain products. What is gain of this loop? Minus G1 H1. What is gain of this loop? Minus G3 H2. What is gain product? Plus G1 H1 multiplied by G3 H2. Is there any combination of three non-touching loops? No combination. So we have delta given by this expression. How to determine delta 1? Remove the first forward path and then apply the same strategy. So we remove first forward path. By removing a path, we not only remove branches but also nodes that are there in that particular path. So if we remove this thing, then what is how many loops are there? There is no loop, no closed path. So delta 1 is 1. To obtain delta 2, we restore this path. We restore this path and remove the second forward path. That is, remove this forward path. So you see that this node is removed. So this is not a closed loop because node is not there. We have removed that one. So delta 2 is also equal to 1. And therefore the transfer function between this signal y5 and the input y1 of S, that is equal to P1 delta 1 plus P2 delta 2 over delta, which is where delta is this expression, right? So you see that application of signal flow graph is quite easy compared to the other technique for block diagram reduction. Any question up to this point? Combination का मतलब कि, for example, if you have this situation, how many loops are there in this signal flow graph? 3 loops. This loop is non-touching with this one. This loop is also non-touching with this one. So this loop is also non-touching with this one. There are 3 combinations of 2 non-touching loops. That is, if you find delta for this graph, so what will be delta for this graph? Delta, first term over here is loop gain for individual loops, sum of loop gains, plus sum of gain product of 2 non-touching loops, all combinations of 2 non-touching loops. For example, this loop is non-touching loop with this one. So what is their gain product? G1, H1, G2, H2. This loop is also non-touching loop with this one. So G1, H1, G3, H3. And this one are also non-touching loop. So G2, H2, G3, H3, right? And then gain product, sum of gain product of 3 non-touching loops, all combinations of 3 non-touching loops. Is there any combination of 3 non-touching loops? Yes, this one, these 3 loops are non-touching loops. So gain products G1, H1, G2, H2, G3, H3, and plus gain product of 4 non-touching loops, all combination of 4 non-touching loops. So there is no combination of 4 non-touching loops, so this term is not here. Clear? Any other question?